Here's an interesting problem using substitution for integration. This one's gonna take some doing. And at first, when my students gave this to me, I said, I'm not seeing it. I'm really not. I knew where I had to start, but man, finding out where it was going, oh, that was awful. And so inevitably, the solution, after I looked in the solutions manual, the solution came to me as, oh yeah, I used to do this with my algebra students, except they wouldn't get it. And so I just stopped. So, all right, so here we go. We want to integrate negative x over the quantity x plus 1 minus the square root of x plus 1. And so what we're going to use is we're going to use our substitution u is equal to x plus 1, which makes it du is equal to dx when we take the derivative of both sides up at the top here. And if we want to rewrite x in terms of u, then it's u minus 1 is equal to x. Now that we have all of those, let's go ahead and substitute this in and see what we get. Okay, so for each u or x plus 1, we're going to go ahead and put a u. And so in the denominator here, we have a u minus the square root of u. Up at the top, we have negative. Now x, in this case, is u minus 1. And at first, you might be doing the same exact thing that I was doing, which is, what? Kind of tilt your head, huh? I don't get it. And I didn't either. Until I realized something here. If you look at the top, and this was kind of the trick that I used to play on my my algebra students. If you look at these two things, they're actually perfect squares. Granted, they don't look like it now, but if you took the square root of u and squared it, minus 1 squared, all of a sudden becomes the difference of two squares. You got to factor it. Okay, so here's the trick in this one. Factor the difference of two squares here for the u minus 1. So you have negative, and this is going to be root u plus 1 and root u minus 1 all over. Now, second trick. Okay, the second trick is factor the bottom. Pull out a root u, and then you'll have a root u minus 1. These are going to cancel out, and you're simply left with the integral of negative square root of u plus 1 all over root of u du. Now simplifying this just a little bit, we've got, this is going to be negative, bring the negative out, and then I'm going to have this piece right here becomes 1 plus, 1 plus u raised to the negative 1/2 du. And now we can go ahead and integrate. And so if we integrate on the 1, we have negative u. And then, oh, let's take this. First, integrate the 1 is going to be u. I'm sorry, I'm going to leave the negative out front. Careful on the signs. U when you integrate 1, and then when you integrate u to the negative 1/2, you get plus u to the 1/2 over 1/2 plus c. Okay. I just put the plus c at the end because it really doesn't matter. You can put negative minus c for all that matters. So it really doesn't, who cares? So, because this c could be positive or negative, so this plus could be positive or negative. It doesn't really matter. So when we go ahead and clean this up just a little bit, we're going to have negative u, and we're going to have minus 2 root u plus c. And there's our answer. Now that we did that, we have to go back and we have to put, remember that u is equal to x plus 1, and that means that this is really the negative of x plus 1 minus 2 root x plus 1 plus c. And there we go. See, nice and simple. hardly even notice it, right? Yeah, it took me a while.